All right, number one, find all values for theta such that theta is in between 0 and 360 degrees. Given cosine of theta equals 0.6541. So first thing you should notice is cosine is positive. Cosine is positive in quadrant number 1. So our answer is going to be that angle right here. It's going to be one of our answers. And our other answer, cosine, is also positive in this quadrant. So the angle theta is going to be quadrant number 1 and quadrant number 4. The first answer you can get in the calculator. Theta is going to equal the inverse cosine of 0.6541. Make sure you're in degree mode when you put this in your calculator. You should get about 49.15 degrees. You could round that to 49.2 if you like. So that's one of your answers. And keep in mind, you can check this. You can go back and substitute this back into the calculator. So for instance, if you take the cosine of 49.15, if you type that in your calculator, you should get approximately 0.6541, that decimal. If you don't, you know you've made a mistake somewhere. Typo in the calculator, something like that. So that's one of our answers, 49.15 degrees. Again, that's the answer that is in the first quadrant. So we need to find what angle forms 49.15 degrees in the fourth quadrant. So it's from the very beginning all the way to this point. We're trying to find that large angle, and to find that, that's going to be 360 minus 49.15. And that will give us our other answer, which is 310.85 degrees. And again, you can type this into the calculator. If you take the cosine of 310.85 in your calculator and you hit enter, you should get a decimal that's really, really close to 0.6541. So you can easily check these on the final exam to see whether or not you've done them correctly. Don't worry about doing number 2. There's a mistake on that. There's no answer for number 2. Let's move forward to number 3. Number 3 is essentially saying the same thing. 0 to 2 pi, if we change 2 pi 2 degrees, that of course is just 360 degrees. So you're looking for an angle in between 0 and 360 that gives you this value for the sine of theta. So again, the first thing you should notice is it is a sine problem and sine is negative. So that means our answer is going to be in the 2 quadrants where sine is negative. So that's this quadrant and this quadrant, quadrant 3 and quadrant 4. So to get your first answer, you're going to type it in the calculator. If you're having trouble typing this in the calculator, let me know. You'll notice you'll get an answer that's actually not one of our answers. You'll get negative 60. That's not one of our answers because we want numbers that are in between 0 and 360 degrees. So we only want the positive values for theta. So what we need to do, negative 60 degrees would be right here. So we just want the positive version of that angle. So we want the coterminal angle of negative 60 degrees. So the positive version of that angle is the one coming counterclockwise, and that is just 300 degrees. So negative 60 degrees corresponds to positive 300. And again, you can check this in the calculator by taking the sine of 300, and it should give you the decimal equivalent of negative radical 3 over 2. So there's one of your answers. Your other answer is going to be in this quadrant, because this is also the quadrant where sine is negative. So you need to find this angle that forms a 60-degree reference angle in the third quadrant. So from the beginning to this point, to find that angle, you're going to take 180 and add the reference angle this time. We're in the third quadrant, so 180 plus 60 is 240 degrees. So 300 and 240 are your two answers. All right, one more of these such problems. Find all values for theta between 0 and 360, given tangent of theta equals a positive answer. So again, we need to find the quadrants where tangent is positive. Tangent, of course, is positive in the first quadrant. And it's also positive in the third quadrant, because that's the quadrant where sine and cosine are both negative. And since tangent uses sine and cosine to get its value, it makes tangent positive since sine and cosine are both negative in this quadrant. To get our first answer, we're going to type it in the calculator. Hopefully it'll give us a positive answer. So again, hopefully you're practicing these on your own rather than just getting the answers, or at least you get the answers and you go back and eventually do these problems on your own. But 30 should be one of your answers. It's positive. That falls within the range between 0 and 2 pi. That also falls in the first quadrant. So you just need to find what angle gives us a 30-degree reference angle in the third quadrant. So to find that big angle from the beginning to this point here, there's going to be 180 plus the reference angle 30, and that's 210. So theta equals 30 degrees and 210 degrees. And again, check these in your calculator like we did the first one to make sure you get that fraction radical 3 over 3. If you don't, you've made a mistake when you're doing this problem. If you need further explanation of that, let me know. Number 5, you're graphing angle theta, 13 pi over 4. So let's convert this to degrees first. So to convert to degrees, you're going to multiply by 180 over pi. You're not given that on the test. That's something you've got to know. I cannot tell you how to do that come test day. Pi's cancel, and it's just 13 times 180 divided by 4. That comes out to be 585. So this is going to be an angle that's wrapped all the way around and then some. So 585. So this is a 1 full revolution around. It's over 360. We're going to take 585 and subtract 360 to see what's left. So that means even after it wraps around 1 full revolution, we're going to go 225 more degrees. So it's 90, it's 180, that's approximately 225. So this is the angle 585 degrees. The next question says find the reference angle. The reference angles formed with the x-axis, the shortest distance. So the reference angle is going to be this angle right here, just this piece. So to find that piece, it's 225 degrees. Subtract 180. There's other ways to come up with that. This angle here is 45 degrees. And notice it actually wants the reference angle in radians. So we need to convert that angle back to radians by multiplying it by pi over 180. Remember, this is just a guide to help you through these problems. If it's not helping, make sure you get the proper help before this test, either during class or in a separate day before the exam. So 45 times pi over 180, that should reduce to pi over 4. To come up with one positive coterminal angle, you can either add 360 to 585, or you can subtract 360 from 585. Remember, we're using this original angle to come up with a positive coterminal angle. So I'm going to subtract 360 just to make it a little bit of a smaller number, make it look more like a number we've used often in class. So 585 minus 360 is 225 degrees. So that's a positive angle. And it's coterminal with 585. And then again, they want it in radians. So multiply 225 times pi over 180 to convert that back to radians. Letter D, find the exact value for the following three trig functions. So sine of theta wants us to find sine of 585. Doing the same problem. Remember, sine of 585 is essentially the same as the sine of 225. But if you type the sine of 585 in your calculator, you get negative 0.707, which we know is equivalent to negative radical 2 over 2. So that's the sine of 585. We're going to do the same thing. Now we're going to take the cosine of 585. Or in other words, the cosine of 225. And you get the same decimal. Which is negative radical 2 over 2. And in the last one, the tangent of 585. A couple different ways to do this, but always check in the calculator and see if it gives you a decimal that you were familiar with. This one doesn't give you a decimal. In fact, it gives you just 1. If you type in the tangent of 585, you should get a positive 1. And remember, tangent is sine over cosine. So in other words, it was this value for sine divided by this value for cosine. And since they're the same thing, anything divided by itself comes out to be 1. All right, moving to the next page. Graph the angle theta. If theta equals negative 150 degrees, then find each of the following. So it's similar to the last problem, except they give it to us in degrees first. Negative 150, so since that's a negative angle, it's going to go clockwise. So we're going to go this direction when we come up with it. Negative 150. So that should be in quadrant number 3. That's negative 90. We just need to go negative 60 more. So this will be the angle negative 150 degrees. Turn that into radians by multiplying negative 150 times pi over 180. Pause it if you need to, if you want to work these out, and then check your answer. You're going to get negative 5 pi over 6. The reference angle in degrees. That's the key right here, in degrees. Make sure you pay attention on the final exam how they want the answer. So the reference angle is, again, the shortest distance to the x-axis. So the reference angle is this angle right here. reference angle is always positive, so even though we're working with a negative angle, that yellow angle is going to be 180 minus 150. So the reference angle is 30 degrees. One positive coterminal angle. Remember, you can add 360 or you can subtract 360, but since it wants a positive coterminal angle, means we have no choice but to add 360 degrees to the angle that was given to us. So negative 150 plus 360 is 210. So 210 is a positive coterminal angle with negative 150. And then finally, find the exact values for the following three trig functions. We're going to take the sine of negative 150. We're going to take the cosine of negative 150. You can just punch this into your calculator. And we're going to take the tangent of negative 150. Don't assume that you're going to get a negative answer for all these. We want exact answers, so we want fractions. The sine of negative 150, of course, that technically you could get away with writing negative 0.5 as your answer, but negative 1/2 is the sine of negative 150. Got that just by typing it in my calculator. Cosine of negative 150, you get negative 0.866. That's a rounded answer. We want exact values. That's the key of this problem. They want exact values. So you need to write the equivalent fraction of negative 0.866, which is negative radical 3 over 2. And finally, the tangent of negative 150, you end up getting a decimal, which is 0.577. We do not want to write that as an answer because we want exact values. We want the fraction form of that answer, but we don't know the fraction of the form of that answer. So we're going to do a little bit of work to come up with this. We know that tangent is sine over cosine. So the tangent of negative 150 is sine of negative 150 divided by the cosine of negative 150. Well, we've already found those two values, the sine of negative 150. We got negative 1/2. And the cosine of negative 150, we got negative radical 3 over 2. Multiply by the reciprocal. So negative 1/2 is going to be multiplied by the reciprocal of negative radical 3 over 2. The 2's cancel. And we get negative 1 over negative radical 3. Negative divided by negative turns into a positive. And then last but not least, get rid of the radical on the bottom, rationalize the denominator. So we're going to multiply the bottom and the top by radical 3. So radical 3 over 3, if you type that in your calculator, it should give you the decimal we got up here. It should give you 0.577. These two answers are the same value. So that's, again, a way you can check your answer. So tangent of negative 150 is radical 3 over 3. This is your answer right here.